Today we're going to be going over Module 2, Lesson 1. So the first thing we're going to talk about is experimental versus theoretical probability. Let's say you have 5 blue bouncy balls and 5 red bouncy balls in a container, and you grab one out at random every time with your eyes closed. It's completely random, and like the odds should be even, right? The odds should be like 50-50 essentially, because there's 5 of each, and you should be getting one red ball, and then the next one should be blue, and then the next one should be red, and then the next one should be blue, right? But that's not actually the case, because you could be getting uh you could just randomly pick out 5 blue ones in a row. It's not likely, but it could happen. It could very well happen. You could choose by random 5 blue ones in a row. But what should happen, or what theoretically should be happening, is uh, you choose, or let's say you get a red one on the first try. You should get a blue one on the next try. And then after that, another red one. Theoretically, right, because it's 50-50, there's 5 of each. Should be a 50% chance of getting either or, but it's not the case. That is theoretical versus experimental probability. The next thing we're going to talk about is odds for and odds against. Uh, so odds for, we can say you have a 4 in 2 chance of uh yeah, of scoring a goal from a certain angle. In soccer, let's say you have a 4 in 2 chance based on your stats from that season that you're going to score in that specific angle or in that specific distance, right? And the odds against that would be 2 to 4, 2 to 4, right? Okay, so this is odds, but if you want to turn that into probability, you'd have to take the number of successful outcomes uh, compared to the total amount of outcomes. So, for example, this would be 4 out of 6. There's 4 successful outcomes out of the 6 possible ones, and this one would be uh, well, I guess it would be the same thing for successful, but let's just say there's 2 unsuccessful events, so 2 over 6. 2 unsuccessful events possible out of the 6 total possible outcomes. Okay, the last thing I want to talk about is non-mutually exclusive events. So let's just say you're trying to find the probability of pulling a king and a hearts, like a card of hearts, for example, which is a suit. Let's say you want to find the probability of of doing that. So first of all, you would get the probability of finding a king, which is 4 over 52, and then the probability of finding a heart or a card of hearts, which is 13 over 52. Then you would subtract the intersect of both, and there's only one king of hearts in an entire deck, so that would be pretty easy. Just 1 over 52. Uh, so you would add these two and subtract it from this, which is equal to 16 over 52. And I'm pretty sure this can be simplified, but this is just how you do it. For non-mutually I'm having a hard time here, but this is basically for non-mutually exclusive events. Okay, so the audio actually cut out for this one, but this is how to find the probability of mutually exclusive events. So as we can see, we have 5 blue marbles, let's say 4 green marbles, and 5 red ones in this container. Let's say, I'm just gonna let it speed it up a bit here. Okay, to find the probability of both, we would just take, okay, 1 second. Okay, to find the probability of both, we would just take the probability of finding a blue, or finding a blue marble essentially, plus the probability of finding a green one, which is 4 over 14. You have to add these two together, and there's your outcome.